Hello, and welcome to this presentation on meshing in Ansys Workbench. This is in preparation for computational fluid dynamics for students who will be using the student software to learn how to use Ansys for fluid dynamics as well as for finite element analysis work. We'll be demonstrating meshing in the Ansys Workbench package. Geometry will have meshing controls applied. You'll find out how to mesh in preparation for computational fluid dynamics. In this demonstration, you will learn how to generate a mesh using the Ansys meshing product. To get started, double-click on Mesh. This will launch the Ansys mesher, loading the geometry we created earlier with Design Modeler. As soon as you load it, there is a yellow lightning bolt by the Mesh branch. Right mouse click, and you can generate a mesh and see a mesh quickly generated using default parameters. It's a hexahedral mesh. The software is smart enough to know if the geometry permits an easy hexahedral mesh, and does so automatically when it can. Most of the time you'll want more control over mesh density, and you can do that either through global mesh controls or with local mesh controls. The global controls are found in the Details area for the Mesh branch. Local mesh controls are inserted at the Mesh branch from the Context toolbar or with a right click. A quick way to modify the mesh is on the Relevance slider, which can go from -100 to +100. On 0, it gives you a default. -100 you get a coarse mesh, +100 it's fine. Let's see what happens at -100. Generate a mesh, and we see a much coarser mesh. If you make it 100, you'll go back to the fine mesh. There's a second center for global mesh density, a relevance center. It can be coarse, medium, or fine. If you try an alternative, generate a mesh, and you'll see a finer mesh. You could even go there and put it on fine. We'll see what that looks like. There's a much finer mesh. We can zoom in and see that fine mesh. Now let's go back to a coarse mesh. Right-click and generate a mesh. But remember, that's with a relevance slider at 100. Let's experiment with some local controls. Right-click on Mesh and insert a method. We have to indicate what geometry. We'll click on that one solid body and apply. Then under Method, go to Tetrahedrons. Let's inspect the mesh with it set to tetrahedrons. And we see the volume filled with tet elements. Another thing is to insert a sizing control. Once again, click on the same geometry and hit Apply. Enter an element size. Now let's generate the mesh. And we see much smaller elements. Element size is being driven by that local control. Another thing to do is to define inflation layers, which helps capture behavior in boundary layers. A high shear area, or it could be of interest for heat transfer at a boundary. Right-click on Mesh and insert Inflation. We need to indicate the geometry. It's the cube. Hit Apply. Now we need to indicate the boundaries. We'll make it the wall, assuming that the front face is an inlet. 4 walls around the perimeter are what we'll select. And on the back face, we'll have an outlet. We want the inflation layers on the walls, so we'll click on those faces, holding the Control key and selecting the 4 of them. Those are the 4 surfaces. We hit Apply. You can see the defaults for inflation layers. It's 5 layers, and we have a rate on there of 1.2 for how rapidly they're becoming larger. Now if we generate the mesh and wait a moment, we have inflation layers where the walls are located. If we zoom in, you can see those layers, helping you capture boundary behavior. The last thing you want to do is create some named selections, making it easier to apply boundary conditions. We'll be choosing faces and bodies and giving them names to assign boundary conditions. We'll select faces. Once again, we're looking at the 4 walls, holding the Control key. Now right mouse click and create a named selection. Give it a meaningful name, in this case walls. Next, we'll use a name to indicate the front face there. Create named selection, we're calling it inlet. Rotate the model, click the back face, and right click, create named selection, calling it outlet. Last thing is to select the body and call that a named selection, and we'll call it fluid. Open the named selections branch that has been created in the outline, and you can see those named selections that we just created. Finally, let's check mesh quality. Open up the statistics branch for the mesh details. You can see the number of nodes and elements. Under Mesh Metrics, drop down and, for example, check skewedness of these elements. You can see the minimum and maximum values for your mesh. A very small number is the minimum, and 0.83 the upper end. You want to keep your maximum skewedness below 0.85, so this mesh will be reasonable. The histogram can be expanded, and you'll see that the majority of elements have reasonable skewedness values, so it should be a good mesh for CFD work. This concludes the demonstration on how to mesh inside the Ansys Mesher product. Thank you.